All right, we are moving on to 1.3. So 1.3, we're talking about solving equations with variables on both sides. So from up to this point, we have just been looking at equations that have variables on one side of our equal sign. So now we're looking at them when they have equal sign or variables on both sides of our equal sign. We're going to skip over these definitions here and just go all the way down to the bottom. So these two shapes have the same perimeter. We're going to find the perimeter of each polygon. If you remember, perimeter means that I'm going to add up the outside. It tells me the outside of my shape. So in order to do that, I just need to add up all of my sides, right? So I'm just going to go around in a circle here. So I've got 5 plus x plus 5 plus 2 plus x plus another 2. And I know that it tells me that the perimeters are the same, so I know that the perimeter of this is going to equal the perimeter. I know that the perimeter of this one is going to equal the perimeter of this one, and so I'm going to set them equal to each other. Okay, this one's a little trickier, right? Because I have two unknown sides here. My first one's going to be pretty easy to find, so I'm going to look at this side right here. If this were a rectangle, okay, this side and this side would be the same, right? So that tells me that this inside part is just going to be 5 minus 4, which is just going to give me 1, right? So this inside one is just 1. I can do a similar thing with this guy here. Okay, so my long side here is 3 over 2x, so 3 halves. Three halves x. And then I can just subtract 3 from it. So this side length is 3 halves x minus 3. So now I can go around and do the same thing. So I've got 4 plus 3 halves x plus 5 plus 3 plus 1 plus 3 halves x. And then I've got plus a negative 3, so I can just write minus 3. Now I'm going to combine like terms. So over here, I'm going to start with my x's. I've got 1, 2 x's. So I've got 2x, and I'm going to add up my constants. 5 plus 5 is 10. 10 plus 2 is 12. 12 plus 2 is 14. So I've got 2x plus 14. I'm going to do the same thing over here. I'm going to start with my x's. So I've got 3 halves x plus 3 halves x. It's going to give me 6 halves x, right? 6 divided by 2 is just 3, right? So I'm going to reduce that to 3x. Then I can add up my constants. So I've got 4 plus 5 is 9. 9 plus 3 is 12. 12 plus 1 is 13. 13 minus 3 is 10. So I've got 3x plus 10. Okay, well now this is something that I can recognize. I've worked with this before. So I want to get my x's together, right? So I'm going to subtract 2x from both sides because I can combine these, right? So that leaves me with 14 on this side equals x plus 10. Now I'm going to get rid of my constant, so I'm just going to subtract 10 from both sides. And then I've gotten my answer, x equals 4. Because 14 minus 10 is 4. Am I done? No, I'm not done yet. What is this asking me? It's asking me to find the perimeter of each polygon. I know that these two perimeters are equal to each other, so is there one shape that seems a little easier to figure out the perimeter of than the other? Probably this guy, right? So I already know that all of my constants add up to 14. And so I've got 14 plus 2 more 4s. 14 plus 8 is going to give me 22. So my perimeter is 22 units. And it will be 22 units for both of them. All right. We have some rules for solving equations with variables on both sides. These are very similar to the rules that we've had before. We're going to rewrite it if necessary, distribute if possible, combine like terms on both sides of the equation. This is the new step, step number 4. I just circled step number 5, but step number 4, that was 3. Almost. Third time's a charm? Nope. Step number 4 is our new, we're just going to ignore that. Step number 4 is our new step. We need to get all of our variables to one side of the equation. And then we'll undo our addition and subtraction, and then undo our multiplication, division, fractions, all of that stuff. Okay, so the only new addition is that we're getting to the variables to one side. When we solve equations that have variables on both sides, I have 3 possible outcomes. The first outcome is that it has one solution. When an equation has one solution, we call that a unique solution. All right, it's a unique solution. Means that it's the only one that we can find. That's it, there's just one. My next outcome is that it could have no solutions. No solutions. Well, no solutions. That's as close as I'm going to get. It can have no solution. There's no way for us to solve it. The last one is I can have infinitely many solutions. Infinite. Let's try one more time. That's about as close as I'm going to get. Okay, we can have, I'm going to write it. Oh, that's not going to work either. Infinite solutions is my third option. We also call this identity. Identity. It's also called an identity. Okay, so I can have one solution, I can have no solutions, or I can have infinitely many solutions. Okay, I noticed, whoops, come on. I noticed earlier that this is the same equation that we did at the front. So we're gonna scribble through this. And we're gonna do a different one. We're gonna do 10 minus 4 10 minus 4x equals negative 9. Come on. Equals negative 9x. Okay, so I want to start this. I can't combine like terms any more than I already have. And so I'm going to start this by getting my variables to one side. So the easiest way that I can see to do that is I'm going to add 4x to both sides. Okay, so then that gives me 10 equals Negative 9 plus 4x is going to give me a negative 5x. Then I can just divide by negative 5, both sides. We've done this a million times, right? 10 divided by negative 5 gives me negative 2, so I'm left with x equals negative 2. Okay, this next one, then, we're using grouping symbols. So this is grouping symbols. We are going to be looking at distributing now. So when I distribute, we learned about this in 1.2. I'm going to bring my 3 to both terms, right? So 3 times 3x gives me a 9x. 3 times 4 gives me 12, but I'm going to keep my minus. Oh, I was doing so good. Minus 12 equals, okay, so now I'm going to distribute again. I've got 1/4 times 32x, so 1/4 of 32 is going to give me 8. So I'll have 8x, keep my plus. 1/4 times 28 will give me 7, right? 7 times 4 is 28. Now I can combine like terms. Well, I don't need to combine on either side, so I'm going to start by getting my variables all together. So to do that, I'm going to subtract 8x from both sides. When I do that over here, I'm left with just x minus 12 equals 7. Okay, I'll add 12 to both sides. And then I'm left with x equals 19. And I'm done, just like that. Okay? So now we're going to look at some special cases, right? So we talked about some equations will have no solution. I'm going to show you how that is. So we're going to start by distributing, right? So 4 times 3d is going to give me 12d. 4, I'm going to keep my minus sign, right? 4 times 1 is 4, so I've got 12d minus 4 equals 12d. Okay, so now I want to get my variables together, right? So I'm going to subtract 12d from both sides. Okay, when I do that over here, I'm left with 0. So, and when I do that over here, I'm left with 0. So I've got negative 4 equals 0. Does negative 4 equal 0? No, that's a silly question, right? Negative 4 absolutely does not equal 0. And so this has no solution. And if it has no solution, then that's just all we're going to write. We're going to write no solution. Right? There is no possible way for me to find a number so that 12d minus 4 equals 12d. No possible way. It's always going to give me something that's not equal. No possible solution. All right, the next one we're going to look at is an example where they have many solutions. We'll start by distributing again. So I've got 8 times 2x gives me a 16x. Eight times 6 gives me a 48, so I've got 16x plus 48 equals 16x plus 48. It's a little wonky, but you get the idea. So I've got 16x plus 48 equals 16x plus 48. It's the same expression, right? So any number that I put in there for x is going to give me, any number that I put in there for x is going to give me an equal equation. I can put any number in there that I want to, and this will still stay true. So in this example, this is when I have, we'll try this again, infinite solutions. All right, let's go over these. So 5p equals 24 minus 3p. So I want to combine my variables. So I'm going to say plus 3p here, add 3p over here. I've got 8p equals 24. I'll divide both sides by 8. I'm left with p equals 3. All right. Next one, I need to start by distributing, right? So I'm going to distribute my 2 to my 3n and to my 4. So 2 times 3n gives me a 6n. 2 times 4 is 8. Keep my minus sign. Half of 10 is 5. And then 1/2 times n, I'll keep my minus sign, is 1/2 n. So then if I want to combine these, I'm going to add 1/2 n to both sides. I'm left with 6.5, I'm just going to do 6.5, n minus 8 equals 5. I'll add 8 to both sides. I'm left with 6.5 n equals 13. Oh, I need my n there. 6.5 n. And then I'm going to divide both sides by 6.5. When I divide 13 by 6.5, I get that n equals 2. Hopefully you can follow all that. It was hard to keep it in the box. Okay, the next one, 3 times 5x, is going to give me 15x. 3 times 2 is 6, so 15x plus 6 equals 15x plus 12. Am I ever going to find a number that will make this true? I'm not, right? Because if I combine these and I subtract 15x from both sides, then I'm left with 6 equals 12. Does 6 equal 12? No, it does not. So this is no solution. No solution. Okay, and then this last one, I'm going to keep this. So I've got 21 minus 7w. And then I've got to distribute over here. 7 times 3 is 21. Keep my minus sign. 7 times w is 7w. So I've got 21 minus 7w equals 21 minus 7w. I can plug any number into this equation and it stays true. So this is infinite solutions. All right, last one. Paul bikes for 3 hours to reach his favorite beach. He bikes 2 miles per hour faster on the way back, so the trip takes only 2.5 hours. How fast did he bike going to the beach? We're going to notice that distance equals rate times time. So my distance stays constant, right? My distance from my house to the beach is the same both ways. So I don't really have to pay attention to distance. I just want to pay attention to how fast I'm going and how long it took me. So it took me 3 hours to get to the beach. So I'm going to start with the 3. Do I know how fast I went on the way to the beach? No, that's what I'm trying to figure out, right? So 3r, that's my rate. 3 times r. I don't know what my r is, but I know that that times this will give me my distance. That is going to equal, took me 2.5 hours to get home. Now I have to write my time in terms of this speed, or I have to write my speed in terms of this speed that I have right here. So it's going to be r. And I went 2 miles per hour faster on my way back. So I went this speed, my original speed, plus 2 more miles per hour. So r plus 2. Whoops, I got rid of everything. Let's go back. Okay, I just wanted to get rid of this. Okay. Now, I'm going to keep my 3r, and I'm going to distribute. So 2.5 times r is 2.5r. 2.5 times 2 is 5. I'm going to keep my plus sign. Now I need to combine my r's. So subtract 2.5r from both sides. And I'm left with 1/2 r equals 5. My last step then is I need to divide both sides by 1/2 r. So, because I'm undoing my multiplication. Now, when I do, well, just 1/2, not the r, right? When I do 5 divided by 1/2, this is the same thing. I've got 5 over 1 divided by 1 over 2, right? 1/2. And so I can apply my reciprocal to this. So that's going to equal 5 over 1 times 2 over 1. Keep, change, flip, right? When we divide fractions, we do our keep, change, flip. So 5 times 2 is 10. So my answer is 10 miles per hour. That's how fast he went to the beach. And that's all we have for lesson 1.3.